Today I'm going to be giving you guys an intro on functions. We're going to start with sets and relations. What is a set? A set is a well-defined collection of objects, and it is represented with a capital letter, let's say A. And inside are curly brackets like this. And elements inside of the set are called elements. So these numbers inside of the set are called elements, and it doesn't have to be numbers all the time. It can be um a can be a word turtle, or it could be anything. It could be a drawing, whatever you choose, but it should be a well-defined collection of objects. What does that mean? What is a well-defined collection of objects? So a well-defined collection of objects is something that everyone can agree upon. For example, if I asked you, what are your 5 favorite foods? You may say pizza, and then chicken or something, but everyone has their different opinions on it. But if I ask you prime numbers less than 13, everyone has the same answer to that. That is 2, 3, 5, 7, and 11. These are all the prime numbers less than 13. And it doesn't matter what capital letter you use. You could use S, and actually we're going to get a bit into this in probability. This is known as a sample space, and we're going to get into that after. So that's a set. A set is a well-defined collection of objects. So I'm going to tell you a few things, and you're going to tell me if it's a set or not. A equals, and there are actually 2 different ways to represent sets. There is the roster form, and there is set builder form. What are these? So the roster form is just writing them out in a list like this. I asked you, let's say the condition is even prime numbers. So what are the even prime numbers that we know? Only 2. 2 is the only even prime number. So A would be 2. So the set is just 2 because it has only one element. And if you want to write this in set builder form, it would be A equals X and 2 colons such that X is an even prime number. So this is how you would represent this in both the forms. Now, we're going to talk about operations on sets. Like, let's say you have 2 sets, A, and this is 1, 2, 3, 4, and 5. And another set, B, this is 1, 2, and 3. And I asked you, what is A minus B? A minus B is equal to whatever elements are in set B, you remove them from set A. So A minus B would be equal to, so 1 is in set B, which is also in set A. 2 is in set B, and that is also in set A. And 3 is in set B, that is also in set A. So you would get 4 and 5. And what about if I asked you A minus B? So let's say A equals A, B, C, D. And B equals 1, 2, 3, and 4. What would be A minus B? A minus B would be equal to A, B, C, and D. Why is that? Because there is no element that is common in both set A and set B. So there is nothing to remove from set A. Now we're going to talk about unions and intersection. Union is basically the combined part of both sets. And we're going to talk more deeply on that. So let's say I have A equals 1, 2, 3, and 4, and B equals 5, 6, and 7. And there is one thing you need to remember. Sets are well-defined collection of objects where no object is repeated, which means no object can be repeated. Let's say there were two fives. That's just not possible in a set because a set has to be a set of well-defined distinct objects. Right. So union is represented like this with an upward parabola. A union B is equal to their combined part. So if you combine both the sets, you're going to get 1, 2, 3, 4, 5, 6, and 7. And an intersection is basically the common part in both the sets. And we're going to talk about that now. An intersection. Let's say I give you a set A equals A, B, and C. And there is another set B equals B, C, and D. Now, what is common in both sets? You can see B and C are common. So A intersection B, this is the notation for an intersection. A intersection B equals B and C. So these are the basic operations on a set. We're gonna get into complements of a set now. What is a complement of a set? A complement of a set is basically, we need to know what a universal set is first actually. Let's say there is a set A and a universal set that contains set A, and it is going to be represented with a U. Not a union or an intersection, but a regular U. So, U is the superset of A. This sign means this set contains every element in this set. So, a complement of a set is basically everything outside of this set that exists in the superset. And you could also say that the union is a superset of A, or A is the subset of the union. I mean, a universal set. So this is actually known as a subset, and we're going to get into that now. So let's say A equals 1, 2, 3, and 4. And B equals 1, 2, and 3. You can see B is a subset of A because every element inside of B exists inside of A. But tell me if this is correct. Is A subset of B? No, this is not correct. Because there are 4 elements in A and there are only 3 in B. For A to be a subset of B, B must contain 4 also. Now we're going to talk about proper and improper subsets. What does it mean to have a proper subset? A proper subset is denoted by this, like this. This means it is a subset or equal to. You have seen this sign, less than or equal to, and this sign greater than or equal to. We can say that 5 is greater than or equal to 6, and we can say 5 is greater than or equal to 5. But can we say 5 is greater than 5? No, we can't say this because 5 is equal to 5. 5 is not greater than 5. But this works because it is a conditional statement, which means 5 is less than or equal to 5. And we're going to discuss that now. Let's say A equals 1, 2, and 3. And B equals 1 and 2 and 3. Let's say 3, 2. So B is actually equal to A, and A is equal to B. But you could also say A is a improper subset of B, and what is it? B. So you could, and B is a improper subset of A. You could do it like this too. And what is a proper subset? A proper subset is when both sets, one set is the subset of the other set, but both of them aren't equal. Like let's say this just had 1 and 2. 1 and 2. If it only had 1 and 2, then B is a proper subset of A. And you cross it out like this. This means it is a proper subset. And a universal set, let me discuss more about the universal set before we get into complements. If this is A, then the universal set exists outside of A, and it contains A inside of it. For example, we have the set of all natural numbers, n, and this is 1, 2, 3, 4, 5, 6, 7, all the way up to infinity. And there is the real number set, and this starts from negative infinity, and it goes all the way to 0, and then all the way to infinity. So all of this part is still part of this. So the real a real number would be the superset of natural numbers. So let's say this is real numbers, and this would be natural numbers here. So you could see that in this case, real numbers are the universal set for natural numbers, and you could take integers too. Integers. It doesn't matter what you take; it just has to be bigger than the given set. Now we're going to talk about complements of a set. If this is your universal set, and this is your A set, the complement of your A set is going to be everything that exists outside of your A set, but is still contained inside of the universal set. For example, if I give you your universal set is equal to 1, 2, 3, 4, 5, 6, and 7, and your A set is equal to 1, 2, and 3, your A complement, or you could also write this as A dash, or, well, that's about it. So this would be everything that exists outside of A, which is 4, 5, 6, and 7. You can even draw it visually to understand. So what's inside of A? A contains 1, 2, and 3. Now outside of A, 4, 5, 6, and 7, which are contained inside of the universal set. So everything outside of A would be a set of 4, 5, 6, and 7. So sets aren't actually numerical values that are assigned. They're actually just an arrangement, a collection of objects. So they're not used mainly in many calculus topics, but they are used a lot in probability. So that's what we need to know. So, what is a symmetric difference of a set? We know what a difference of a set is, A minus B. But what is a symmetric difference? A symmetric difference is A minus B, and you take the union with it of B minus A. And this is a symmetric difference is represented like this. A triangle B. How does this work? Let's say you have a universal set, and this is your A set, and this is your B set. A and B. A minus B would be everything that doesn't have B. And B minus A would be everything that doesn't have A in B set. And so if we take the union, we get a symmetric difference, A triangle B. Now we're going to try to visualize all these operations on sets visually. So first, we have A complement, and this is going to look something like this. So this is your universal set, and let's say this is your A set. This is your A set. So everything outside would look something like this. So let me erase this a little bit. Okay, that's good. So this would be your complement of a set. Now we're gonna talk about a minus b. How do we draw a minus b in the form of a Venn diagram? We take our universal set and we have our a set and our b set. A minus b would be everything inside of a that doesn't have b, like this. And the same way you could say b minus a is everything inside of a, inside of b that doesn't include a. And if you take the union of both, then you get your symmetric difference. So this is your symmetric difference of a set. And a plus b and a, so there are two ways to represent a union. That would be a plus b or a union b. It doesn't matter which one you do because they are the same thing. So if we have a set and we have b set, so a plus b or a union b would be the combined part of both sets. And we take everything only once. We don't repeat anything in sets. And a intersection b would be the common part of both sets. Let's say this is set A, set B. So this part right here would be A intersection B. Now we're going to talk about disjoint sets. What are disjoint sets? Disjoint sets are where A intersection B equals 5. What is 5? This is 5. So phi is a Greek letter invented to represent a void set or a null set. And we're going to talk about what that is. If I ask you, give me a set of um even prime numbers less than 2. So we know 2 is the only even prime number. Now, how do we get a prime number? So 2 would work. This would be the answer to your set if this was less than or equal to. But that's not the case here. We're just asked less than 2. And 2 is not less than 2. So, how would we represent this? A equals an empty set, which means there are no elements in this set, or phi. So that's what phi is. And disjoint sets are where A intersection B equals phi, which means that there's nothing common. Let's say I give you A equals 1, 2, 3, and 4, and I give you B equals A, B, and C. If you take A intersection B, there is nothing common, so it's phi. And the graphical or Venn diagram way to approach this is, let's say you have your A set and your B set. So actually, this is not the correct way to draw this. So this is A, and these don't touch because there is nothing in common. So these are disjoint sets. Disjoint sets. So today we learned the basics about set theory. Tomorrow we're going to go deeper into set theory, talking about operations on symmetric difference, disjoint sets, and proving how to prove two sets equal if they are subsets of each other. So I hope you enjoyed this video, and I'm going to see you tomorrow.